Let's now talk about the concrete events for our refinement model M1. Overall, there will be 3 events that we need to speak about. Let's just give you some overview quickly. We have the special event init, which will initialize all the variables for the refinement model, meaning that when the system is first launched, how should the initial configuration look like? And we also got the final events, which like O events, which is inherited from the abstract model M0. We spoke about it already, but it has a different definition right now because it has to adapt to the new variables that we declare for the refinement model. We'll see that. And we have a new event called receive, and this event is really elaborating the intermediate transformation process that we spoke about. Of course, for the init event, it's kind of special. For that, we only need to prove that it actually establishes the invariance. And for these 2 events, we have to prove that they actually preserve the invariant condition for the new and also the old events. And for the new events specifically, we also need to prove that it does not cause any divergence or life lock, right? Remember the requirements for proving that the refinement is actually valid. We are not going to necessarily show you all the proofs, maybe only to show you some of them. But for the remaining ones, you're supposed to do them as exercises. Let's now go back to the slides. We'll talk about the definition for each event, the guards and the actions one by one. Let's talk about the init events. So initially, before the transmission is started and completed, we want to set up things to begin with. That'll be the init events. Let's now see the hints, and then I'll let you pause the video and think about what you should really put down as the actions. Remember, for the init events, we don't have any guards. It's unconditional. So the transmission process has now been completed. How do you specify that? And also, nothing has been transmitted to the receiver. So you want to say that the receiver, from the receiver end, nothing has been received. And also, from the sender side, the first file element is available for transmission. It's only ready, but it's not being transmitted yet. So these are the 3 aspects you would like to address in the actions of the init events. All right, you can now pause the video and think about what kind of formal actions you need to perform for the init events in order to satisfy these. Alrighty, assuming that you thought about it, let's now go one by one. The first one, the transmission process has not been completed. That one should be rather straightforward because we're using a Boolean variable to indicate whether or not the transmission has been completed, right? So that means initially, we should really say over here, this one over here, number 1, we should really say the Boolean variable should be initialized to false. So that'll be the first one. What about the second one? Nothing has been transmitted to the receiver, right? You can see initially, nothing has been transmitted to the receiver, meaning that H over here is simply just empty set. And we can say H becomes empty set. What about the third one? The first element is available from the sender side for transmission, meaning that the value for R is really conceptually pointing to the first elements at index 1 over here. So how do we specify that? It should be R, it becomes just 1. So these are the 3 actions you have to specify for the init events. You can think about this part over here is really being set up by the init events, this part over here, right? Let me just write it down. So this part over here is really set up by the init events. All right, that's rather straightforward. Let's now talk about the intermediate transmission process in the middle. So while the transmission is ongoing, we might just expect 1 or more occurrences for the receive event, depending on the size of the file from the sender side. If the file contains only 1 element, in that case, only 1 occurrence for the receive event will actually take place. Otherwise, it might be multiple occurrences. Right, so we may have some guard to specify under what circumstances will the receive events be enabled for occurrence. And also, once it is enabled, what kind of actions should it really perform to update the variables, the concrete variables more specifically. Right, the first one, we want to say while the sender has more file elements available for transmission. So this seems to be like a guard, the guarding condition. You want to say the receive events, we can receive more to the receiver side as long as some condition here is satisfied. That condition there, we should really say we have more elements available for the transmission. You want to say that the current R, the pointer value is really pointing to some valid position, right? That's something you want to specify, right? I'll just give you a little bit of hints over here, so you can think about how to specify that precisely. So, given that the receive event is actually enabled, meaning that we have at least one element more from the sender side to be transmitted, what should we do? Action number 1, we want to make sure whatever that's actually available will be received and accumulated to the receiver's copy. Let's go over the actions, and then I will visualize it for you. And the next one, the sender's next available file element is updated, meaning that, let's say, if the second element has been transmitted, the pointer R should be updated to 3, just for the next receive event to occur. And how do we turn these two informal descriptions into formal actions? Let me visualize them to you so you will have some idea, so you can pause the video and put down your answer. Okay, let's take a look. Let's say here we got, how many occurrences of the receive events do we have in this example? We have occurrence number 1, occurrence number 2, and occurrence number 3. We got 3 occurrences. Let's say for the very first occurrence over here, you can see before the receive occur, we got R pointing to index 1. In that case, we want to make sure after the receive has actually occurred, we can accumulate the H from empty set into a non-empty set, in which case we're going to transmit exactly the A over here into, let me use a different color, from the A over here to the A over here, right? That's something we also illustrated earlier. To be more precise, think about this particular receive event is going to trigger 2 updates. Number 1 is going to make sure H is actually is going to become, the current one is actually empty set before the receive. And then union with, over here, we only want to transmit only this one here currently before the receive, because R is pointing to 1. So that'll be 1 and then A. That's all we want to transmit. And after transmission, the H is going to become exactly this, right? And that's the index, of course. That's number 1. And number 2, we also want to make sure after transmitting the first elements, R is actually going to be incremented, and then it's now going to point to B, which is ready for transmission for the next receive occurrence. So R should also become R plus 1. In that case, it's going to become actually 2 over here. Right, let's do one more, and you will see the pattern. What about the second events? The second occurrence for the receive events over here. Right, we're going to do the similar action. Number 1, we're going to accumulate before the second occurrence, H has already received index 1 elements. So that means it has 1A. That's already this. I should say H will become the following. And union with, and before the second occurrence, what do we have on the sender side? R is actually pointing to index 2. Right? So that means we really want to transmit to B. And after this particular union, we're actually going to have exactly this one here in the post states that's being transmitted to the receiver side. So that's why after this, you will see exactly this. Let me just make some color here. So we're going to transmit exactly this to over here, right? And number 2, we also want to make sure the sender side, after transmitting index 2 elements to the receiver side, we want to increment it so that the next one will be ready for transmission for the third occurrence for receive. So that means R is going to become R plus 1 again. So these are the 2 actions that need to be kept executing whenever you have one occurrence for the receive. And for this one here, what should be exactly the 1 and 2? That would be your exercise. I can put down, right? What should be 1 over here, and also what should be 2 over here, right? Exercise for you. This could be some warm-up exercise before you come up with the general pattern for the 2 actions. Right? Let's now go back to what should be the guard and what should be the 2 actions over here we should put for the receive based on the hints I gave to you over here and also the visualization I just did together with you. Right? You can now pause the video and put down your answer. All right, assuming that you thought about it, for the guard, let me use the blue. For the guard over here, we want to make sure the receive over here can occur as long as we got the R pointing to some valid index. You can see think about after the third occurrence of the receive, the post state is such that R is now pointing to somewhere that's actually not a valid index. R over here is actually 4, as we said before, right? So the R over here is actually equal to 4. In that case, it's not valid index anymore, meaning that there should be no more receive events to be occur, right? So we want to make sure R is less than or equal to the maximum index. So what's the maximum index? Should be n, right? This is the maximum index, less than or equal to n. That'll be the guard. What about the actions over here? And we got 2 actions to worry about. And the first one should be H becomes H union with, and what should be that expression? If you look at previously, we actually got over here, you can say union with 1A and also 2B, right? Exactly what we union with depends on, you can see the 2 over here and also the 1 over here. They really depend on, in the pre-states, what the value is for the R over here, and also what the value of R is over here, right? That's kind of the correspondence you want to notice. That should be exactly equal to whatever R points to, and also the corresponding elements in the sender file. It will be very important for you to see this. Right? You want to see this correspondence over here to what I showed to you earlier. All right, and that's it. That's about the 2 actions and the guard for the receive events. And let's now move on to the final events. And the final events will be over here. Basically, as soon as the receive becomes disabled, that means the final should be ready to take place. Let me write down that insight for you. As soon as receive becomes disabled, the final should be ready to occur. Right, so any system trace that we have should be a single init followed by 1 or more receive and then ended with a final events. Right, so this part over here is really the final events that you want to make a notes. Okay, the final. So as soon as the receive becomes disabled, the final should be ready to occur. Let's take a look at the hints, and then you can also pause the video and talk about it, think about it. Actually, there are some more bullet points I want to go over for the receive before we get to the final events. In this concrete model, M1, the first refinements, there is something that's not so realistic, which I'm going to go over with you, give you some idea. The receiver have access to the sender's private variable R is kind of unrealistic. What do I mean? You can think about when we try to come up with the receiver events over here, we're trying to use R. Okay, so I'm going to write it down for you. You can see the R over here, and also the F over here, and also R over here, right? So all these should be sender private info. That has to do with how exactly the sender actually manages its internal structure about what the file is, and also what the current elements that's available for transmission, right? So these information should be very private to the sender, and they should not be public to the receiver. But somehow the receive events, of course, that should be taken by the receiver. They can actually get access to these variables. So this is not so realistic. What we really want to do ultimately, maybe in a later refinement, is to say we're going to hide these two variables from the receiver, from the receive events, and we're going to establish some communication mechanism between the receiver and also the sender, so that we can hide these private variables from the sender to the receiver, right? That's something I want to point out as well. So the sender's private info should be hidden. Right? That's something we'll do maybe in a later refinements. All right. Yeah, in a later refinement, which will be refinement number 2. And finally, let's say talk about after the transmission has been completed, it should be denoted by an occurrence of the final events. Let's talk about the guard and also the action. So we say when the sender has no more file element available for the transmission, meaning that the R is really pointing to somewhere that's not valid index for the file for the sender array. In that case, that would mean we are now ready to conclude the transmission process. Right? That will be the guard for the final event. You can think about exactly how to specify that. And what should we do when the transmission is over? We simply mark the transmission to be completed. And not more complicated than that. And that's it. All right, let's now let you pause the video and think about how you will put the guard and also the action for the final events. Think about it. Alrighty, assuming that you thought about it, let's now see the answer. What about the guard? So when the sender has no more file element available for transmission, what does that mean? So let's now write it down. So the guard should be that when if the sender has no more element to be transmitted, so that means the R over here should be pointing to something that's one off the maximum index, right? So we can write it down precisely. That would be when R is exactly equal to n plus 1. Number 1. Number 2, we better also make sure implicitly, if you actually want to mark the transmission process as completed, it better be that currently it's not being completed yet. We can only take the final event only once. You don't want to say after receive we still allow final followed by final followed by final followed by final. We only want one single final event occurrence. Okay, let me write it down. So that means we should also put B is currently false. And this will be also very important to see why. We also need this guard here as well. So this one will make sure occurrence of number of occurrence of final is restricted to just 1. That's also very important for you to see why this guard is going to make it happen, because after the action over here is going to set B to be true. As soon as we set the B to be true, that means the any later occurrence of final is going to be disabled because B has already become true. So it's not enabled anymore. So final should only occur just once. What about the action? Well, we're going to mark that the transmission is completed. So we're going to say over here, the B will be true. Right? As easy as that. But I think maybe the trickier part is about how to understand the receive, because receive can actually occur more than one times. It's possible, depending on the size of the sender's file. Alright, so that's about the 3 events we have to watch out for. And again, you want to really be clear about the nature of the 3 events. Let me recap and then we'll move on to the proofs for the refinements. The init events is a special event for which you only have to prove about it can establish the invariant conditions. The final event is the O events that's inherited from the initial abstract model, for which you have to prove about the invariant preservation. And for the new events, there are several things you may want to prove. Number 1, you want to prove about its invariant preservation for sure, and also number 2, guard strengthening, and also number 3, divergence freedom. Right? These are the three things at least you have to worry about for the refinement, especially for the new events. That's something we we introduced to you thoroughly in the bridge controller example. You may want to refer to them about how to apply the pattern for this example over here. Right? For that, I'm going to leave that to you as exercises. Alrighty, let's now move on to proving these events.